Hi guys, welcome back to the channel. Today we are going to be solving today's lead code question. So before diving into the question, turn on your DSA mode and then let's get started. We are given a head of the linked list and then we need to delete the consecutive sequences of the nodes that sum to 0 until there is no such sequences. After doing so, return the head of the final linked list and then you may return any such answer. So we need to find, we are given a head of the linked list and then we need to remove the sequences where the sum of those particular nodes values will be 0 and then we need to remove those. Suppose let's take this particular example. Here if we see here 1, 2, minus 3. The sum of all these elements is going to be 0. So we need to remove all these nodes and then we will be returning only 3 and then 1. So this will be the answer for this. So we need to remove the nodes which sum up to 0. So let's consider how we can solve this. Suppose let's say this is the linked list. Now we need to remove the nodes which have the sum equal to 0. Suppose consider this case like 3 like 4 3 and then minus 4 and then minus 3. Suppose if we do the sum of these nodes, then it becomes 0. So we need to remove all these nodes and then we need to attach 1 to 7 and then we need to return back 1 and 7. So how can we solve this problem? Suppose let's say we traverse the linked list from here to here and then here to here and then here to here and then here to here. After coming here, how can we get to know that the sum is 0 at this particular point and then it started from here? Suppose let's take like this. Now we should we should find out that if this particular sum of the values ends here, then what will be the starting point so that sum of these particular nodes will be 0. Suppose consider prefix sum. The sum of all the previous elements will be 1 and then for this will be 5 and then for this it will be 8. Yeah, this will be 8 and then for this will be 4 and then again if we come here it becomes 1. So if we consider this particular case, whenever we have some prefix sum 1 and then the previous prefix sum is 1, then we can say that there exists a node where it starts from 4 and then ends at minus 3 and then those elements will be sum equal to 0. So what is the possible reason for this to have the same sum? Suppose let's say I have sum of all the elements as sum and then I have element x, all the elements as x and y. This is some sum and then this is some particular sum. Now we will say this is equal to sum. Then that means x plus y, whatever the in between sum, this is going to be 0. So if the previous sum is same as the current sum, then we can say this in between sum is going to be 0. That means whenever we have particular one sum, then if we have previously one sum, then that means the elements which are in between those elements sum will be same particular sum. So for this particular case, we will get to know the point where it will have the current node and then we'll see that this particular node has a next node and then we'll have, let's say this is the node and then this is another node and then this is another node and then this is the another node and then this is the another node. Now we have all the prefix sums. So whenever we have prefix sum, this is where it starts and then this is where it ends, this particular zero sum. Now we need to match this next pointer to here. That means we need to store this particular node in the hash map, so that whenever we want one node, which is one node, and then we are going to take this next to current node next, so that will store in the map. And then one more thing is, suppose let's say I have 4, that means the prefix sum 5 will be inserted, and then whenever I have 3, and then 8 sum will be inserted. Suppose let's say whenever I come back here, it is going to be 8, the sum is going to be 8, and then at that particular point, then we should remove the elements which are present previously. Suppose this is 8 and then this is 8, that means we need to remove all these elements, so that we will not say this is the node which we want to remove. That will not be possible. So we'll try to figure out that whenever we have this particular node, all the nodes which are in between these nodes will be removed, will be removed from the hash map. So let's go through the code. Here we have zero sum, remove zero sum sublist, and then we have this particular map where it will store from sum to node. This will be stored from whatever the prefix sum is there, and then it will be mapped to node, and then this will store the total value, total sum value, and then we are going to have current node and then previous head. Suppose let's say there is a head, we will have the previous head such that whenever the head itself changes, we'll store previous head next as another node, so that we'll return the previous next. Suppose let's say this is the head itself, and then we want to remove head itself, then we'll remove head and then we'll have another node. Instead of changing that, we'll have the previous head as our static, and then we'll map previous head to head, and then whenever we want to change it, we'll change previous head to some other nodes, so that we'll return at last previous head next, and then previous head will be mapped to previous head next is going to be head, and then sum of node of 0 is going to be previous head. Why? Because whenever we have sum equal to 0, that means whenever we have 4 and then again minus 4, then we need to remove these particular nodes. That means the previous head must be mapped to other node, and then current node will take it as head, and then we'll move until it becomes null, and then we'll add the sum value to current node plus value, and then whenever we have this particular sum previously had in the map, then we can say that there exists sum of the nodes that is equal to 0. Then we need to erase all the nodes which are which we need to remove. So we'll do the same thing. So we'll take the sum of node from these nodes, we are going to add the value, and then we are going to remove this particular sum, and then we'll move node to node next, and then at last we are going to add the sum value to next, and then this sum node next is going to be current node next. So if we see this particular example, this becomes 0, so we are going to map sum of node to next to current node and then next. So that is going to be the case, and then we'll map current node to sum of nodes, so that whenever we want, this will be the current node, we'll we'll say current node equal to this, and then as it is connected to this, current node next is going to be moved like this, and then again it goes to null. And then whenever let's say we do not have any node where the sum equal to 0, then we need to store that in the hash map. So whenever we have sum, we'll store it in to the current node, and then whenever we come up with the same sum, we are going to see what is the node present, and then we'll see that these elements sum will be 0, so we'll be doing that, and then current node will be moved to current node next, and then at last we are going to say previous head next. So for this, time complexity is going to be big of n. Why? Because we are going to traverse the linked list once, and then if you want to remove those nodes, it will be big of n itself. Like we'll remove all the nodes. That means it needs to travel again, so that will be big of n, and then the space complexity is going to be big of n. Yeah, that's all for this video. And one more thing, like the space complex, the time complexity is going to be n log n. Why? Because we are considering the map, so the insertion and deletion of the map is going to be log n, so it is going to be n log n. Yeah, that's all for this video. Thanks for watching.